This question has two parts to it. In part A, you're asked to sketch a cubic, which is quite straightforward. But in part B, you're asked to transform that cubic, which is not so straightforward. So we'll start by setting up some axes. Here's my y-axis and my x-axis. And I'm looking at this f of x here, which is 2 minus x squared multiplied by x plus 1, and I'm wondering, where does this equal 0? So it equals 0 when either of the factors are 0. So when 2 minus x equals 0, which gives x equals 2, or when x plus 1 equals 0, when x is minus 1. Now the 2 is repeated because there is a repeated factor of 2 minus x. So that's when x equals 2 twice in that cubic expression. So let's put those on. So when x equals 2 and when x equals 1 is when I should be crossing the x-axis. I should also be crossing the y-axis when x is equal to 0. So if I put x equal to 0 in the original expression, so 2 minus 0 is 2, I square it, it's 4, and I multiply it by 0 plus 1, which is just 1. So I should be crossing the y-axis at 4. So let's just put 4 there. Okay, so what is the shape of this graph? So I can see that when I multiply out that I'm going to have a cubic term. And that cubic term is going to be positive because there's a minus x being squared multiplied by an x. That's the highest order term. That's the only one I need to consider when thinking about the shape of this graph. So I need to make this shape fit on my graph, making sure that I bounce on and off the x-axis at this point. So let's try and get that like so. That's good enough. Okay, so that's the answer to part A. I've considered the roots, the y-intercept and the shape, and I've put that all together to get my answer to part A, sketching my cubic. So in part B, I have to use part A to sketch the graph of g of x equals this. Now if you compare that with f of x, we can actually see that x is being replaced with x minus c. And I can see that more clearly if I write g of x equals 2 minus x minus c in that first factor. But it's really obvious in a second. I don't need to change the second factor there to see that x is replaced with x minus c. Now x being replaced with x minus c is a transformation in the x direction. Now if c was positive, this would be an extra transformation which shifts my curve from where it is to the right by c. I always think it's going to do the opposite to what it actually does. So we think it's going to go back by c, but actually it goes to the right by c. That's if c is positive. However, I am told that c is between minus 2 and 0. So actually it's going to shift my graph by an amount that is between 0 and 2 to the left. So let's put some new axes on. The relevance of this, in fact I need to move that over. Let's put my y-axis over here a little bit. The relevance of c being between minus 2 and 0, where c was originally moving it to the right, but actually it's moving it to the left because it's negative. The relevance of it being between minus and 0 is that this root will not go past the y-axis if the amount it's moving to the left is less than 2. So let's put that here and my minus 1 here, but these have new coordinates. So what are my new coordinates? 2 plus c and minus 1 plus c. Bear in mind c is negative. So it is going down. These numbers are going down. So let's get the repeated root on here, bouncing off, and then the single root just cutting through. So now we also have a y coordinate here. Let's zoom in and tidy that up a bit. the y coordinate, which is found by putting x equals 0 into the new expression. So g of x, or g of 0, is 2 minus 0 minus c squared, and then 0 minus c plus 1, or let's write that as 2 plus c squared multiplied by 1 minus c. So we can label that there. 2 plus c squared, 1 minus c, completing the sketch of g of x. Okay, check out studywell.com for more.